All right, today we're going to crack open one of the coolest and honestly most powerful tools in machine learning, the naive Bayes classifier. You're about to see how this surprisingly simple algorithm is kind of the secret agent that's quietly sorting our entire digital world, one guess or, well, one probability at a time.
I mean, think about it. How does your inbox just know what's spam? It's something you deal with every single day, right? You open your email and poof, your inbox has already done all the heavy lifting. So how does it make that call so fast and, most of the time, so accurately? Well, the secret sauce here is a process called classification. And really, at its core, that's all we're talking about here. Classification is just, sorting things into different piles. It's the simple act of putting stuff into buckets we've already labeled. Is this email spam or is it not spam? That's the fundamental job that an algorithm like naive Bayes was born to do. So, let's dive into that a little bit more. We're going to talk about the everyday problem here, because trust me, this isn't some dusty academic theory, it is absolutely everywhere.
Seriously, just think about your day. You're scrolling through product reviews. Are they positive or negative? That's classification. You're browsing a news site. Are the articles about sports, politics, or tech? They're already classified for you. And yeah, of course, the big one, the spam filter. All of these are just classification questions that need answers, and they need them fast.
And that right there brings us to our hero of the day, naive Bayes. This is the algorithm that steps up to the plate to give us those fast, reliable answers. So, let's meet the thing. Okay, this one sentence right here, it basically breaks down the entire idea. So, we know it's a classifier, right? It sorts things, and it's built on something called Bayes' theorem, which is all about probabilities. But then there's that word naive. I want you to really hang on to that word because it's the secret to its whole superpower. So what in the world is Bayes' theorem anyway? Let's not get lost in the math. Just think of it like this. You're a detective. You walk onto a crime scene with an initial hunch, right? A starting belief. Then you find a clue, maybe a footprint. That new evidence makes you update your hunch. It either gets stronger or weaker. That is all Bayes' theorem is doing. It's just a formal way of updating our beliefs when we see new stuff. Okay, so now it's time to pop the hood and see how this thing actually thinks. How does it go from an email to a decision? Let's walk through its logic, step by step, and we'll stick with our spam filter example. So, the very first thing the algorithm does is look at what it already knows. This is called the prior probability. It's like its background knowledge. Based on, say, the thousands of emails it's already seen, it has a starting point. For example, it might know that, historically, about 60% of all emails are spam. This is its gut feeling, its baseline, before it even glances at the new email. Okay, now it starts playing detective. It starts looking for clues inside the email itself. This part is called calculating the likelihood. It asks simple questions like, all right, how often does a word like free show up in emails I know are spam? And then it asks the same question for emails that are not spam. It's gathering evidence, word by word. So let's just put that all together into a simple process. Step 1, it starts with its prior belief, what it already knows about spam in general. Step 2, it calculates the likelihood. How likely are these specific words to appear in spam? Step 3, it combines those two probabilities. And boom, step 4, it just picks the category with the highest final score. Is it more likely to be spam or not spam? That's it. That's the whole game. All right, now we get to what I think is the most fascinating part of this whole thing. We've talked about the Bayes' part, the probability stuff. But what about that word naive? This, my friends, is where the algorithm gets its secret superpower. I mean, seriously, why call it naive? Is that supposed to be an insult? Like it's simple-minded? Well, no, not at all. In fact, its so-called naivety is exactly what makes it so incredibly smart. So here's the deal. In the real world, we know that words have context, right? The phrase free money means something very specific. The words depend on each other. But naive Bayes, it makes this huge, almost crazy assumption. It says, I'm going to pretend every single word in this email is completely independent of every other word. It just ignores all grammar, all context, all relationships. It sees each word in a total vacuum.
And here it is, the big reveal. That assumption is, of course, completely wrong. We know language doesn't work that way. It's a rich, tangled web of connections. But here's the absolute magic of it all. Even with that fundamentally naive worldview, the algorithm works shockingly well. For sorting text, it's a rock star. That simplification isn't a flaw, it's its greatest strength.
So you might be thinking, okay, in a world of giant complex AI models, why are we still talking about this simple little algorithm? Well, it's because that naive assumption we just talked about is exactly what makes it so useful and relevant even today.
Think about it. Because it makes that simple assumption, it's crazy fast. It doesn't need a mountain of data to get going. It works great even with smaller datasets. It's easy to implement. And, maybe most importantly, it's an amazing baseline. It's the first thing you try to see how well a simple model can do before you bring out the big guns.
And because of that, you see it everywhere. I'm talking way beyond just spam filtering. It's used for sentiment analysis. Is this movie review good or bad? It helps power recommendation systems. It's even used in medicine to help with initial diagnoses based on a list of symptoms. It's incredibly versatile. This table really puts it all into perspective. You can see how naive Bayes stacks up against some other common algorithms. Look, something like a random forest might give you very high accuracy, sure, but look at the speed. It's slower. Naive Bayes? It hits that sweet spot. It's very fast with moderate accuracy. And for a ton of real-world problems, that trade-off is absolutely perfect.
So, look, if you only remember one thing from all of this, let it be this little mental model. All naive Bayes is really doing is asking one simple question over and over. Given the clues I'm looking at, which category is the most likely explanation? That's it. That's the core idea.
And that kind of leaves us with a bigger question, doesn't it? Naive Bayes teaches us a lesson that's not just about code. We live in a world that's always chasing more complexity, bigger models, more data. But this simple algorithm is a great reminder to step back and ask, is a simple guess sometimes better than a complex one? Sometimes the most powerful move is to just be a little bit naive and ignore all the noise.